Hello everybody, good morning. I hope everybody doing good. Today we're going to have Octal System. It's the last system that we'll have it in this series, in this first course Foundation Level 1. It's about Octal System. Octal System, it's existing now, it's not widely used, but you as a developer, you should to know what is Octal System. So let us see what is Octal System. But before to see what is Octal System, let us go over the system we had them before. We have a system, we have them before. So let us account them together and remind ourselves these systems. First system we have it is decimal system is base 10. Base 10 we say is the normal system that the human use it or the people use it in their life every day. It's your phone numbers, bank account numbers. You create from it hundreds, thousands, million, billions. This is the decimal system base 10. It's the ordinary system that the people use it in their life every day. And we have also before we had binary system. Binary system we said it's base 2. And
the computer rely on it so much.
Computer take any language and represent it or change it to binary system, because computer is an electric device and prevents or allows electricity. So 0 or 1, on and off. For that, we had before binary system, and we also take some examples and homework on it. And binary system we said is base 2. And we had before also hexadecimal system. Hexadecimal system, we said it's base 16, and developers use it so much in their work because it's more human friendly and readable, and we will use it also so much in roadmap, web application roadmap. So hexadecimal is base 16 and more readable, and it's make it easy for developer to read the binary, because the binary is not human friendly, and the hexadecimal is a system, it's base 16 human friendly. And we said also that each byte it's represented with 2 digits in hexadecimal. And today we have the octal system. The octal system is base 8 from 0 to 7. Today we're going to have octal system. Octal system, it's base 8 from 0 to 7. All right. The octal numbering system is very similar in principle to the previous hexadecimal numbering system. What does this mean? It means that both system, hexadecimal and octal system, both of them human friendly. Like more of them, it's easy to developer to read them. They are more readable. It's easy to human to read it. Human friendly both of the both system, hexadecimal and octal system, except that in octal, each octal digit represents 3 bits. So 6 bits are 2 octal digits. What this means, you will understand it later in this lesson. I know it's a little bit confused, this sentence. All right, now I have table for you. This table, as you see, character A in octal system, it's 101. Character A, capital letter, character A in hexadecimal is 41. Character A in decimal system is 65. I just give you this table to have a clue later in future. When you see OCT, you know this is octal system. When you see HEX, you know this is hexadecimal. When you see DEC, you know this is decimal system. So I put this table to give you clue in your future. When you see these things, you know this is belong to which system. All right. Why octal system? Why octal system would exist? First, let me ask you a question. If I ask you the byte, how many bits in the byte, you will answer me 8 bits. That's good. That's correct. All right. And if I told you, if I want to represent 2 digits in hexadecimal, each digits in 1 byte, it will take how many bits? You told me each digit, it will take 4 bits. Before, in octal system, each digits, it was taking just 3 bits. Previously, on all computers, the byte was only 6 digits and not 8 digits. It doesn't mean that octal system, it's base 6. It's still base 8. It doesn't change anything. It's still base 8 from 0 to 7. Octal system, put it in your mind that it's still base 8 from 0 to 7. But each digit in octal system, it's represent 3 bits, not 4 bits like hexadecimal. In octal, a binary numbering is divided up into group of only 3 bits. Okay, let's have an example to understand it. We have octal number, it's 101, all right? We want to change it to binary. When we want to change it to binary, if you recognize now, you will see number 1, it's represented in binary in 3 bits, 001. This is 3 bits, because we say in binary each bit, each bit in 1 bit, it just hold 1 digit, 0 or 1. So now we have 3 bits together in binary, 001, which means 3 bits. 3 bits is represent 1 octal digit. As you say, number 1, front of it, it's 3 bits. Number 0 is front of it 3 zeros, which means 3 bits in binary. Another number 1 is also front of it or represent in binary 3 bits, 001. Together, when you put them together, it's give you these binary number 001, 000, 001. You will ask me now how the octal system is base 8, and this octal number 101 is give me 9 bits together, like 001, 000, 001. This is 9 bits, and the octal system or the byte generally, it's contained from 8 bits. How it's give me 9 bits together? It shouldn't work. I told you it's work, and it's stretch about the number that you want to represent it. For example, when I give you in the hexadecimal lessons 6 Fs, we say 6 times of letter F represent white color in color picker. That 6F, it doesn't mean that we take it from 1 byte. No, we say in hexadecimal, each 2 digits, it's represent for us, it's coming from 1 byte, and 1 byte is 8 bits. So 6 times of F letters that is represent white color and color picker, which mean we have 3 bytes. 8 plus 8 plus 8, 8 plus 8, 16, 16 plus 8 is 24. So to represent 6 letters of F, 6 times of letter of F's in hexadecimal, we need 3 bytes. And same here, to represent 3 digit of octal, that was hexadecimal. When we want to represent 6 F's, 6 digits in hexadecimal, we need 3 bytes. Here, when we want to represent 3 digits in octal, we need 1 byte and 2 bits together. That's how computer was working. That's how computer was working in all time, 1950s, 1955, 1960s. Each octal digit, it's represent in 3 bits, not 4 bits. And we say in hexadecimal that 4 bits together, it's mean nipple, and 2 bits together, it's mean crumb. In octal system, it doesn't exist. This, it wasn't exist at all. So don't say 3 bits, it's nipple for octal. No, it's not nipple for octals. Nipple is just used with hexadecimal, and with nowadays computer and system, each 4 bits give us 1 nipple. But before, it wasn't something called nipple or crumb and these things. So together, 001, 000, 001, leading zeros help show dropping the binary number. What does this mean? We have something called leading zeros. It's easy information, but you should to know it. Leading zeros, it has example for it. Leading zeros are simply the zeros at the beginning of a number that don't change its values, which mean we have here binary number 0010. So it's the same as 10. If you erase them, it's okay, it's stay 10. Here in binary number, the second one, we have a lot of zeros and we have 1. So it's the same, it's 1. If you erase all zeros before the 1, it will stay the value, it's 1. While our binary number before it, some zeros, it doesn't change the value, you can erase them, you would just leading zeros number of binary. If you want to erase some zeros here, we will erase the first 2 zeros. 0, 0, we will erase it. We will just leave it 1, 0, 0, 0, 0, 0, 0, 0, 1. So we'll start with 1 and we'll end it with 1. And between it, the zeros and the 0 before the 1 in the beginning, we could erase them, and it will never change the value of octal system digits or number 101 that represent character A. So is the octal system not widely used nowadays? As I said, it's used, but not so much in some embedded system, and not so much used because most modern computers use nipples, which is hexadecimal 4 bits together. It's give us, we take in byte parts lesson that we said 4 bits together, it's give us 1 nipple. So because most modern computers use nipples, they no longer base their word length on multiples of 3 bits. They not use 3 bits nowadays, they not use octal. Instead, they are now based on multiples of 4 bits. So hexadecimal is more widely used. Hexadecimal is more widely used in octal system. While even octal system, it's human friendly and more easily readable than binary, and it's so close to hexadecimal. But it's not used because the modern computers use nipples, which mean 4 bits. All right. So as I said, both hexadecimal and octal system provides a human-friendly representation. For example, if I told you this binary number, it's easy to you to read it, or 212 in Octal system, it's easy to read it, you will tell me 212. It's more easier to me as a developer to read it than hold this binary number. All right, good. If I do a small comparing between octal and hexadecimal system, so if I told you it's more easier to read 212 or D4, you tell me D4, it's more easier to read than 212. So D4 in hexadecimal, it's also more easier than 212 in octal system. For that, hexadecimal, it's more widely used nowadays. And we talk also before, we take also before in hexadecimal, listen, prefix. I give you prefix of hexadecimal. It starts with hashtag, and for example, after that, 6Fs. And we take some languages, a program like C, C++, Java. We said we start with 0x, and after that the code, and XML also, and Unicode also prefix. We said U plus, and after that the code. This is prefix of some languages that I give you in hexadecimal lesson. Just I give you a clue about it, and to explain to you that we have something called prefix before the code. The octal system has prefix. Yes, the octal system. I bring you this table and I repeat again the prefix because I want to tell you also that the octal system also has prefix, and its prefix, it starts with 0O, and after that the code. For example, 00725. Okay, now let us go and see how octal works, how octal system works. All right. So remember this, but before we go to see how octal system work, we should to remember that binary is base 2 and hexadecimal is base 16 and octal system is base 8. Why we need to remember this? Because we will do the same process of the math that you do it in hexadecimal with octal system now. But we should remember it's base 8, which means we will divide it, we will convert this number 469 to octal, the same process, like the same process of hexadecimal. If you did the homework, it will be piece of cake for you, this process now, or this math now. So we will take the number 469 divided 8. Why 8? Because octal system is base 8 from 0 to 7. And we got result. We will put the result in the result column, and we will take the integer number, put in integer column, and fraction, and remainder we will multiply it with 8 because octal system is 8. And we got octal number. Let's see how it's work. 469 divided 8 is give me 58.625. So we take the integer number 58, we put it in integer column, and we take the fraction number 625, we put it in fraction column, 625, and we take the fraction, we multiply it with 8. Why? Because it's base 8. Octal system is base 8. So the remainder, we will say in the remainder, 8 multiplied 0.625 is give me 5. While we say also in hexadecimal, we say while the integer number still bigger than the base number, which means here 8, 58, it's bigger than 8. So while 58 is bigger than 8, we will repeat the process or the math. So 58 divided 8, it's giving me 7.25. We will take 7, we put it in integer column, we will take the 25, we put it in fraction, and we will repeat again in remainder. We say 8 multiplied 25 is giving me 2. So also we said that while the integer number it's less than the base number, it will give me the same number in the end. For example, the integer number, the last integer number here is 7. It's less than number 8. It's less than base 8. It's less than 8. So 7 less than 8, it will give me also 7 in the end. As you see, 7 divided 8, it will give me 7 in the end. It will give me the same number, while the integer number, the last integer number, less than the base number. 7 is less than the 8, number 8. So it will give me the result. It will be number 7. So how we read now the octal system? How we read it? We read it same exactly like hexadecimal, from down to up, 7 to 5. 7 to 5. So 469 in base 10 decimal system, it's exactly same 725 in base 8 in octal system. All right, this was for today. and I have just a small homework for you to convert just two numbers for me. And this system is not widely used anymore. I just want you to know that there is something called Octal System and have clue and some information about it. And for that, the homework is so small and not that heavy at all. So I want you to convert those decimal numbers to octal, 64 and 330. I'll see you next lesson, guys. And listen, most of you're gonna hate me because I will make all this process of hexadecimal and binary and octal system more easy with calculator, because we have something called calculator programming. We will have it in the next lesson. So see you next lesson, guys. Ciao.